Hi everybody, my name is Krishna and in this video series we are going to learn about the FPGA prototyping. In this series we will discuss how to write the RTL codes, how to write the constraint file, how to synthesize them, and finally how to implement them on a FPGA board. So the mission and objective of this series is to demonstrate how to write the codes that are actually used for prototyping of the FPGAs. So the core hardware we are using for this series is this. This is the VSD Squadron FM, which is developed by this board is developed by the VLSI System Designs, and the chip the FPGA chip which is working on it is the Lattice ICE 40. So taking to the specification of this board or the chip, it's having 5.3 Ks of the lookup tables, the memory of 1024 kilobytes of the SRAM, and finally it's having a 32 GPIO pins for the interaction with the environment. This is going to be the learning path of our series. First we'll learn about the simple setup for the programming of this FPGA, then we'll gradually move to the logic and then bigger circuits like FSM, SOC, and finally we'll discuss at the last of the series how to design a RISC-V softcore processor on this FPGA board. The tools we are using for the programming of this FPGA, the first one is the VSys. So you have to download the VSys. It's open source, completely available on GitHub. And this VSys actually help us to synthesize the design, converting our RTL design to the netlist. Next is the next PNR. So it's actually used to integrate our constraint file and to write the implementable file for the processor, this FPGA board. And finally the iStorm, it's actually used for the programming for this FPGA. So this is going to be the series. The first video is going on to series introduction, which is this video, and the second one will be the Linux setup, and gradually move to the other series. So stay tuned about this series. We will actually discuss, interact, how to do the debugging, how to prototyping, how actually use the application of the FPGAs. Thank you.